we're going to start our notes on 4.4, Fundamental Theorem of Calculus. Everything you've done in 4.1 was dealing with indefinite integrals. I'm going to write down that this is indefinite integrals. And remember that name, integral, is synonymous with an antiderivative. So this is what we were doing before in section 4.1, derivative. What we're going to do now in 4.4 is we're going into definite integrals. Indefinite, indefinite. What's the difference? These little numbers. We're going to add a number at the bottom and the top of our integral symbol. The way that I remember this is I think of these integral symbols, indefinite, I think of as undefined, or I think of it as, well, we don't really have an interval that we're using. Here we have a defined interval for the integral. We are going to go from 0 to 4. We want the specific integral from 0 to 4. That's what we're going to do. So that's how this changes a little bit. Whereas these were for the whole function, this is going to be specifically from 0 to 4. This is kind of defining what your domain will be. This is defining what your domain will be. Your smallest x value would be 0. Your largest x value would be 4, from 0 to 4. Which brings us to the fundamental theorem of calculus. Let's write that down. Fundamental theorem of calculus. I'm abbreviating at this point because we already wrote it down at the very top. The fundamental theorem of calculus says if f is continuous, from along the interval from a inclusive to b inclusive, from a to b, and big F is the antiderivative of little f, then the integral from a to b of f of x d of x would equal big F of b minus big F of a. I'll read this to you again. This says the fundamental theorem of calculus, if little f is continuous along the interval from a to b, and big F is the antiderivative of little f, then the integral from a to b of f of x d of x of the little f of x d of x is equal to big F of b minus big F of a. There was a question, Matt.
So the definite interval is still the same as the antiderivative?
Yes. We're just going to be doing it along a specific point, and I'll explain in just a second. So let's start off with something that you know how to do, and I'll show you how this is going to change what you did in 4.1. In 4.4, we're going to change a little bit what we did in 4.1. But most of you understood what we did, so let's just try this out. Let's find the integral from 1 to 4 of x squared with respect to x. We're going to find the integral from 1 to 4 of x squared with respect to x. So I think most of you actually still remember, if I were to ignore this 1 and the 4, you guys should know how to find the integral of x squared with respect to x, right? It would be x cubed over plus c. Okay, so I've actually taken the integral, haven't I? Okay, so let me show you what the textbook authors do, and I'm going to tell you to do it too. They put this stuff in brackets so that you know that we've done the integral part. We've already taken the integral of this, but we haven't done anything with the 1 and the 4 yet. So we still need to do that as a part of this problem. We just haven't done it yet. And so as a way for me to show my work that I know how, I've already taken the integral now. I just haven't done anything with the 4 and the 1 yet. We're going to show that outside this bracket. If it was a single thing, I would only need a single bracket, but because there's two things in here, I have a bracket on the left side and the right side. It's kind of weird, but that's what your textbook does. When I look at how they do this on page 276, let me show you what it looks like on 276. Zooming in. So they've taken the integral of little f of x, and look at, there's only a single bracket on this big f of x. How come? Because there's only one thing there. It's only one term. But if there are two terms, let's go down a little bit lower. If there are two terms, they put a bracket on the right-hand side and the left-hand side. But for short, if there's only one term there, terms are separated by plus signs and minus signs, they will only use one bracket. And that's what we will do as well. Kind of funky how that works, but we'll just go with it. Okay? Going back. So now I still have to apply this fundamental theorem of calculus, which is pretty simple. It just says, hey, plug b into the antiderivative and plug in a into the antiderivative. So which one's b? B is the bigger number. B is the top number. B is the bigger number into this function. So now I'm going to plug it into this up there. And basically it means I need to plug the 4 into the x to the third. So it's going to be 4 to the third over 3 plus c. Don't know what c is, so I'm just going to leave it there for right now. And I'm going to subtract, this is our f of b, by the way. And I'm going to subtract f of a. That means I'm plugging in the smaller number in. 1 to the third plus c. And I'm keeping it in parentheses so I can stay organized. Trevor?
Will it always be the biggest number for b?
They should always go from smallest to biggest, yes. It should go in the same order.
It's always positive.
No, you could have negative values there. But you go from smaller to bigger. I'm trying to think of, I've never seen one that goes the other direction, so I'm not quite sure on that. So I'm not going to do anything that's not in order. I'll just put it to you that way. Okay, so now let's simplify this. And 4 to the third is 64 thirds plus c minus 1/3 plus c. When I distribute this, or no way, there's distribute the negative sign. I have 64 thirds plus c minus 1/3 minus c. And what happens with the plus c and the minus c?
They cancel out.
Will that happen every single time using the fundamental theorem of calculus? Yes. It will. The c's always cancel. And so because those c's always cancel, when you use the fundamental theorem of calculus, you do not have to use c as part of the integral anymore with definite integrals. But for indefinite integrals, you will still need to have the plus c. I'll say that one more time for emphasis. You need to have a c when there is an indefinite integral. Like I said before, where there's no numbers here, when you integrate, there is always a constant of integration. But for definite integrals, when we're doing from 0 to 4, Because we're using this fundamental theorem of calculus, when we subtract one from the other, the c's will always cancel, so you don't need to have them anymore as a part for the section 4 type of problems. Make sense? Okay. So now, what's our final answer? What is 64 thirds minus 1/3? 63 thirds, which reduces to 21 is our answer. Okay, 21. Why 21? Ms. Prama, what does it mean? It should be your next question.
Nothing.
It means something. This is the area. Let me show you visually what I'm doing so that you understand where this just went. When I graph, hang on, Cody. Let me get this idea first, and then I'll answer your question. When I am graphing x squared, when I'm graphing this integrand right here, x squared, you guys know what that graph looks like, don't you? What is it? It's one of your parent graphs, right? It's a parabola. It's a pretty sorry parabola, but here's this parabola nonetheless. If I were to integrate it from 1 to 4, here's 1. When I plug in the number 1, I'm at 1. When I'm at the number 4, what number am I at? Okay, so I'll put 16 way up there. Okay, so it hits 16, 4, 16. What we're really finding when we're integrating is between the function and the x-axis, what we're finding is the area underneath the curve.
That's not okay.
So I'm shading that in. 21 is the units. If this was 1 inch and this was 4 inches, then it's 21 inches squared is the area below this curve. It's the area between the function and the x-axis. By the way, can you have a negative area? Sure. It just means, in calculus, it means that the area is below the x-axis.
So do you need to put units in your answer?
Nope. We're just going to put 21 because there were no units here or anywhere else, so we're just going to write down 21.
What do you mean below that? So,
For example, if I had a picture, same graph, let's do x squared minus 1. Okay? And if I was integrating x squared minus 1 with respect to x from -1 to +1, visually, what would that look like? Here's the parabola shifted down 1, right? At -1, when we plug it in, is what? 0. When I plug in +1, what is it at? 0. Technically, we're finding this area, the part that I've shaded right there. Do you see it? Since that area is below the x-axis, this area mathematically will come out negative. So why don't we do that? That'll be our first example. Example 1, we'll call it. I want you to find the area below the curve from -1 to 1 of x squared minus 1 with respect to x. You may work together, you may work by yourselves, it's up to you. I want you to find this area, compare your answers, help each other out as you go.